of convection, and here you have temperatures prevailing T1, T2, and then here T infinity, it is 30 degrees centigrade. Now, let me find out what is R insulation. R insulation is equal to 1 by 2 pi KL ln higher radius by lower radius. That's R1. So what is R2 actually here? What is R1 first? R1 is 3 mm by 2. And R2 is 3 mm by 2 plus the thickness 2 mm. So,
Sir, T infinity should be on the insulation side, no, sir?
yes, I have taken on the insulation side only. This is the insulation side.
Sir, on like you do the
Meaning you are saying that T2 itself is 30 degrees centigrade, isn't it? That's
no,
what
sir.
you understood.
It should be towards T1, no, sir.
Hmm?
Sir, you put T. Okay. T1 as R insulation.
Yeah. So this is equal to 1 by 2 pi. The K value is given as 0.15 and the L value is given as 5 meters into Ln. What is the higher radius? It is 1.5 plus 2, that is 3.5 by 1.5. Somebody tell me this value. Also, I need R convection. It is 1 by HA, which is equal to 1 by H into 2 pi R2L. That is equal to 1 by H value is given as 12 into 2 pi into the R2 value is 3.5 into 10 to the power of minus 3 into the L value is 5. So tell me these values. What are the values you tell me?
R insulation is 0.1798. 17.
0.1798 Kelvin per watt. Good. R convection ma? This is what I have with me. Kindly cross check. 0.76 Kelvin per watt. That's what I have with me. If I'm wrong, kindly correct me. Okay. So these are the resistances. And what he's asking you to find is the temperature. Interestingly, he's asking you to find the T1 value. What is T1? You have to find out. So how can you find it out? Somebody tell me. Q is equal to T1 minus T infinity 1 by the R insulation plus R convection. We know this. In this, he's asking you to find T1. You know R insulation. R insulation you have found out. R convection you have found out. This one you know. Do you know this Q? This is asking you to find. Do you know the Q here? See, in the problem, what he has done is he has given you the voltage and the current. So if I multiply the voltage and current, you will get Q. So T1 can be obtained from that. So what I can write is T1 is equal to Q into R insulation plus R convection plus T infinity 1. So that will be a T1. So what is Q value now? The voltage into current, 10 into 8. 10 into 8. R insulation value is 0.1798 plus convection value is 0.76 plus T infinity 1 is 30 degrees centigrade. I can write. Yeah. Somebody tell me what is T1 now?
105.01 degrees.
105.01 degrees centigrade. Good. So you got T1 now. Okay, this is your T1. This is what he's asking you to find, and you have found out. Okay. Now, the point is here he's asking you to compare, also determine whether doubling the thickness of the plastic cover will increase or decrease the interface temperature. So this is what I'm trying to discuss with you. I'm trying to prove this point actually, whether the temperature, whether the thickness of the insulation, whether it will increase the temperature or decrease the temperature, whether it will increase the heat transfer or decrease the heat transfer. So that's the point. So for that, let us take the doubling of the thickness. Okay. Doubling of the thickness means if R2, if R2 is equal to 3 mm by 2 plus 4, because initially you have 2 here. If I double it, it will be 2 into 2, that is 4. That is 1.5 plus 4 will give you 1.5 plus 4 is 5.5 mm. So now for this R insulation, you have to find out. It is 1 by 2 pi KL ln R2 by R1 again. It is 1 by 2 pi. The K is 0. 0.15 into 5 into ln. The higher radius is 5.5 by the lower radius is 1.5. R convection is equal to 1 by HA, that is 1 by H into 2 pi R2 into L. This 1 by the H value is given as 12. 12 and it's 12 into 2 pi into R2 is 5.5 now into L is 5. Okay, so tell me these values now. Now they'll change.
R insulation 0.275.
0.275, and here
0.482.
0.4.
0.482.
0.48 Kelvin per watt. Good. So, yeah. So you have these values, and now you calculate this T1 using this. So
90.56.
T1 is equal to T infinity plus Q into R insulation plus R convection. Substitute all those values here. You will get, somebody told me that it is
90.56.
90.56 degrees centigrade. Okay. So this is the temperature that is required. Right. Now, see, if the thickness is small like this, okay, the thickness is 2 mm. Here, the thickness has increased this much, and it is 4 mm. So here you have a temperature T1. Here you have temperature T1. In this case, the temperature is 1. T1 is 105 degrees centigrade. And in this case, the temperature is 90.56 degrees centigrade. Am I right? If I'm wrong anywhere here, kindly correct me. It is 105.
Correct, sir.
Yeah,
Correct.
thank you. So
Correct.
this is what you have the temperatures. Let me keep it aside and let me calculate what is the critical radius of insulation. If I take critical radius of insulation, it is K by H, isn't it? So the K value here is 0.15 and the H value here is 12 mm. 12 watt per meter square Kelvin. So tell me this value. What is this value?
0.0125.
0.0125 meters. If I take it in radius, it is 12.5 mm. Okay. And here, what is the radius in this case? What is R2 here? It is 3.5 mm. Here R2 is 5.5 mm. Right. See, from this, what we can understand is till 12.5, the heat transfer will definitely increase. Okay. Till 12.5. So if I have to show it as a graph here, if I have to draw Q versus the radius, okay, especially the R2. If I draw the diagram, this is how it will be like. This is how the graph will be like. Now, here, this point is your R critical, which is 12.5. And somewhere over here, we have here 5.5, and this is your this is R is equal to 3.5, and this is right here. This is 3.5. This is 5.5. Right now, see, if this is the case, the heat transfer is going to increase and then decrease. So, since you have maintained here, it is less than the critical radius of insulation. What is happening is here the temperature has decreased, meaning the heat transfer that is prevailing over the thickness has influenced and it has increased. That's the point. See, here in this problem, basically Q is same here. It is 10 into 8 and Q is equal to 10 into 8 here. That's why you may not exactly appropriate this particular concept into this, but this can be understood from the temperatures here. The temperatures are 105 and 90.56. Okay, so from this, I can conclude one thing very clearly. That is, see, you cannot keep on increasing the thickness of your insulation. Let us say, you are designing what should be the thickness of the wire. A copper wire you have designed and you want the thickness of it. So how do you decide? You cannot go on increasing the thickness. If you go on increasing the thickness, you can understand from this concept that the heat transfer will increase, and if the heat transfer increases, your wire will get melted. Okay, when wire is getting melted, you are not designing it properly. So if you keep on increasing the thickness of that particular wire, no, the insulation thickness, if you keep on increasing, what's happening is you are not going to help the wire perform better. We are actually trying to damage it. Okay, because when you keep on increasing the thickness, the heat transfer will increase to a certain level. When it increases to a certain level, what happens is you will be having the melting of the wire will get melted. So the thickness that is there on the wire will be well understood when you have the appropriate thickness. Okay, so based on this concept only, I'll take one more problem tomorrow, maybe in the next class, that will give you even better clarity. I hope I'm clear so far. If you have any doubts, you can ask, and then we will conclude.